Hello everyone, and welcome to Office Hours with the Meter Environment team. Today's session will focus on water content measurement methods, and we're shooting for about an hour of live Q&A with our experts, Leo Rivera and Chris Chambers, whom I will introduce in just a moment. But before we start, we've got a couple of housekeeping items. First, we want this session to be interactive, so we encourage you to submit any and all questions in the questions pane. We'll try to get to all those questions. If we don't, which more likely we won't, someone from our science and support team will get back to you with an answer via the email you registered with. Second, if you want us to go back or repeat something you missed, don't worry. We will be emailing you a recording of the session within the next 3 to 5 business days. All right, with all of that out of the way, let's get started. Today, our panelists are research scientist Leo Rivera and application specialist Chris Chambers. Leo operates as a research scientist and hydrology product manager at Meter Group. He earned his undergraduate degree in agriculture systems management at Texas A&M University, where he also earned his master's degree in soil science. And there he helped develop an infiltration system for measuring hydraulic conductivity used by the NRCS in Texas. Currently, Leo's the force behind application development in meters hydrology instrumentation, including the HYPROP and WP4C. He also works in R&D to explore new instrumentation for water and nutrient movement in soil. Chris Chambers operates as the support manager at Meter Group. He specializes in ecology and plant physiology and has over 13 years of experience helping researchers measure the soil-plant atmosphere continuum. So, thank you for joining us, guys. All right. Let's get started taking questions. Thank you to everybody who's sent in questions already. Remember, you can submit questions in your questions pane at any time during this event. All right, so our first question today looks like it's about tensiometers. So they're asking, can we measure the potential difference between 2 points in millimeter precision?
So what's that convert? Is it a kilopascal or heptopascal? That's 1 centimeter.
Yeah. So with tensiometers, typically with the especially with the ones that we make, the most we can resolve down to is a hectopascal, which is the equivalent of a centimeter of suction. Essentially, it's slightly different. But so to get into this question, the answer is ultimately no. We can't go down to that level of precision. But that seems pretty. I don't think you really need to be that precise. I mean, a hectopascal is a pretty high resolution on water potential anyways, and really that's what you should be looking at. And you can put 2 tensiometers, for example, into a soil profile or a soil column in the lab and start looking at fluxes using tensiometers, which is what we do with tools like the HYPROP as well.
And what's the uncertainty in the TRS-31? It's like,
so the uncertainty is a half a kilopascal.
Okay, gotcha.
But the precision's pretty high, and I think on average they typically perform better than that anyways. Okay. But when we're looking at any type of water movement or fluxes in soil, I mean, a hectopascal is about as good as you're going to get.
Especially over any distance with spatial variability, you should still get a really good signal there.
Yeah. Now, if you're trying to look at water level fluctuations to millimeter precision, then you need to look at different tools. You need to look at something like a water level sensor. If you're looking in the saturated zone, and if you're looking in the unsaturated zone, then the best you're going to get is a hectopascal. But you can really get great information out of that. I mean, looking at unsaturated hydraulic conductivity, just looking at water movement in general, and looking at these fluxes and where the water is moving. I mean, there's so much information you can get out of that level of resolution and accuracy, anyways.
Right.
So they can be a super powerful tool.
All right, our next question here. They're asking, diel or diurnal water content fluctuation has been an interesting phenomenon that they've been recording for the last decade in semi-arid grasslands. When and how can we move forward with the interpretation and publishing of what this diel water content fluctuation means?
Right. And this really cuts to the heart of picking out the signal from the noise. If you're interpreting water content data, looking at this variability and understanding the sources of it is going to be important for interpreting your water content data in the end. Now, it's kind of a signal to noise problem because you can get hydraulic redistribution in certain systems where you've got a deeper source of water. Plants can actually lift water up into other soil layers.
Yep.
So it looks like you're getting this increase in water content, and you are at a certain spot, but it might not be intuitive because higher sensors may not be showing that. You may not have any precipitation, so you're like, where is this water content coming from?
Yeah.
The tricky part is that depending on the sensor as well, there can be some sensor noise based on temperature.
Based on temperature. Temperature
affects the dielectric permittivity of the soil. That's a pretty well characterized relationship, right?
Yep.
So if your pattern doesn't follow what you would expect from temperature, then you might be seeing some hydraulic redistribution or something like that. It's a really tricky topic, and I think it's tough to tell if that's what you're actually seeing or seeing some sensor noise.
Yeah. And I wonder if sometimes what helps if you're trying to look at and differentiate between temperature sensitivity and actual hydraulic redistribution is, I think typically the hydraulic redistribution is going to be, the peak is going to be slightly offset from the temperature peak, right? Because typically that's more of an ET driven value, and there's going to be some lag in that fluctuation.
Yeah, that's right.
I think that's maybe one way to kind of dive into that.
I think that's a good point. And there has to be a source, right?
Yeah.
So there's got to be a deeper source of water. You may not be able to see it, great question. I don't have all the answers. It's fantastic biophysics, especially with root anatomy. And that's a great question. Part of it is understanding your sensor.
Yeah.
Like you said, does it follow the trends that you would see in temperature? What is the temperature sensitivity of the sensor that you're using?
Yep.
Some older echo sensors that were produced as decagon have a higher temperature sensitivity than the Teros line.
Yep.
But you can still see a little bit of temperature sensitivity in the Teros line as well.
Yeah.
This next one, they're asking which sensors and applications are adequate for measuring water in individual potted plants and the whole nursery.
I think it ultimately comes down to the sensing volume, right, Chambers?
Sensing volume, definitely. And where, what's the size of your pot? What's the rooting of your sensor like? How often do you repot? So there's a lot of variables, and we don't have one silver bullet recommendation to solve the entire problem here. But look at the size of your pot. Choose the sensor that's going to fit comfortably within your pot.
Yeah.
One of the biggest problems we habitually see is a sensor that has a sensing volume too large for a pot, especially if you're using a small pot.
Yeah.
And then the distribution within a pot, it depends a lot on your substrate as well. There are some specific recommendations if you're using something like rock wool. And then in a peat perlite mix, really just determining where to put the sensor can be the challenge.
Yeah, I think that's the biggest, once you get the sensing volume nailed down, the next question is where you place the sensor in the pot. Where do you place the sensor? And you oftentimes see people making the mistake of putting the sensor too low in the pot, where because it's a zero tension lower boundary, it's going to saturate, and you're actually not getting a representative measurement of the pot. And so understanding how water is distributed in your pot, I think, is really important when you think about sensor placement.
And it's a tricky one. And there's so many different combinations between crop and pot between crop, substrate, and the size of your pot.
Yeah.
It's really difficult to make a one size fits all.
Yep. I mean, there's definitely tools out there to help kind of identify, like if you know your retention properties of the substrate, then you know your pot size, you can kind of use some rough calculations to determine the sensor placement or what's an optimal sensor placement once you know the sensing volume.
Right.
So anyways, if you have questions about that, you should reach out to us.
Next question is related to that. The dielectric permittivity changes a lot from the type of soil mix and also pot size, Kc from each plant, and salinity increased by fertilizers, the age of the soil in the pots, over 1 to 3 years or so. So which will be the key indicators for watering, hydrozoning, and programming that you indicate here?
There's a really tricky topic touched on here, and that's the salinity.
Yeah.
our current line of sensors, the TERO sensors, they're pretty robust to salinity up to a point. And if you cross that line, you'll see it in the data. Beyond about 10 decisiemens per meter, saturation extract EC, your water content data can go crazy.
Yeah.
And you can hit that level in artificial substrates, especially with high rates of fertilizer addition.
Yeah.
So keeping an eye on that is really important. We have some sensors coming down the road that will be more robust to that, but we can't talk about that too much right now. So definitely keep an eye on what's happening with the salinity.
Yeah.
Other key indicators for watering, that is a lot of salinity aside, knowing your crop and your substrate.
Yep.
Those are going to be, I think, your two most important things. And there's going to be a strong interaction there.
Yeah.
So something, say if you're growing a tomato crop in soils, you're going to have really different refill points and you're going to want to manage it differently than if you're in, say, a peat perlite mix or something like that.
Yeah, and it also depends on the growth stage you're at for the plant.
Vegetative versus...
Yeah.
Yep.
And, I think we know that most soilless medias have a pretty low inherent dielectric permittivity. It's the salinity that's really the key factor that increases that.
That's right.
I mean, we've done hundreds of soilless media measurements of different types of media, and overall they perform fairly similarly when you take the salinity factor out of it.
That's right. So. And you don't necessarily need to know the absolute accuracy of your sensor.
Yeah.
As long as you understand the set point that you're looking for, or your refill point, the sensor can give you an objective measurement of your water status.
Yep.
Even if it's not necessarily giving you the most accurate reading at the time.
Yeah. Next two questions from the same individual, basically just saying that they're getting weather stations and sensors per meter. So any help for installation? So I guess any tips to avoid any future issues would be helpful. They're also asking which infrared cameras that we would recommend.
So for the weather stations, we do as much as we possibly can to minimize the installation headaches, right? I recommend going with an Atmos 41W. It's got a leveling plate right on there. It's solar powered. The data goes straight to the cloud. It's really going to reduce a lot of your opportunities to make an error. Level it, point it north, and you're in great shape.
Yep. And if you have any soil sensors that you're installing, follow our installation guidelines that we have out there. We have quite a few resources available. Mm-hmm. But for example, for soil moisture sensors, you want to minimize air gaps. And if you can minimize soil and site disturbance, that's super powerful. So that's why tools like the installation tool have been great in improving these capabilities.
Yeah, we'll have the new and improved installation tool coming out, so keep your eyes open for that.
Yep. And, I think the other key part is once you get the sensors installed, like the weather station and the soil moisture sensors, cable protection and cleaning.
That's right.
Especially for the weather station, right? Bugs, bird, pooping. Sorry, I couldn't think of a better word. Bird feces.
Yeah, pooping was fine. I don't know why you weren't comfortable with pooping.
But yeah, ultimately making sure that you don't have a clogged rain gauge, and take care of your gear. If you're not out there checking on your site, but once every 6 months, there's a good chance you might have problems.
Keep an eye on your site. Cloud data is great. It also shows you when you have problems with your data, so that you can get out there and check it out. And one last thing, depending on what you want to use the data for, there are some standards out there. If you want the top-notch, absolute best weather installations, you can look at the World Meteorological Organization. They have some standards for installing and the weather stations themselves.
Yeah. I don't know. I haven't personally worked with infrared cameras. I don't know if you have, Chambers.
I'm like the last person you should talk to about infrared cameras. Sorry.
So we're going to have to say you reach out to the experts on infrared cameras for that one.
Next question, are there any special considerations for very rocky soils or areas where the soil water content is typically very low? They're asking specifically here for the Mojave Desert, but there's plenty of other places all throughout the world with similar situations.
Data quality in rocky soils or low water content soils.
Yeah, I mean, there's definitely challenges in sites like that, right? I mean, especially, and maybe the question is, are you trying to avoid the rocks? Are the rocks just part of it? Like what is the distribution of rock to soil kind of mixture? Because sometimes that's just a part of the substrate and you measure it. But
installation, they're definitely a problem.
Yeah.
Because rocks can break sensors. Even an installation tool doesn't really help you in that kind of case. So installing, assume you might break a couple of sensors and have a couple of extras on hand. And then installation tools really don't help in this case.
Nope.
Because, unless sometimes you can't even feel you're hitting a rock with the installation tool. You look down your hole, you see that it didn't go in, you pull it up, and it's completely mashed because the tool gives so much force. So consider your options there. A shallow borehole or a trench might be just as well. And then if you get a lot of resistance, stop because I don't know of any soil moisture sensors that you can just install straight through a rock, right?
Yeah. No.
So the best you can do is move it. And the most important thing for getting good data with soil moisture sensors, at least most soil moisture sensors on the market, is good soil to sensor contact.
Yeah.
So installation, be mindful of getting good contact with your sensor and not having air gaps from the rocks.
Yeah. What do you think, Chambers, about also the idea of also measuring water potential in these low moisture environments? Do you think there's any benefit to that?
Maybe, it kind of depends on what your soil water retention curve looks like.
Yeah.
Actually, I think more and more that having a good matrix potential measurement is just always going to be helpful.
Yeah.
Depending on the questions that you're asking, especially.
Yeah.
But I think more important in those low water content, or as important, is a very precise sensor. Because if you have a sensor that has plus or minus 3% from sensor to sensor variability, you're almost always comparing sensors in this case. And if your maximum water content is 5% and your error encompasses your entire observable range, you're going to have a hard time drawing conclusions for that. The Terrace 12 and Terrace 11, their 95% confidence interval for sensor variability is 0.011 meters cubed per meters cubed.
Yeah.
That's not a published spec, but we have a lot of information on that. And so they're going to be some of the best sensors that you can use in that case.
Yeah.
An EC5 or a 10HS, those have a little bit more variability from sensor to sensor. It's going to be a lot harder to draw conclusions when your range is so tiny.
Yep. Yeah. So installation,
and watch out for the biological crusts out there, especially if you're in the Mojave.
Yes.
Be careful. Go for minimum disturbance.
Yeah.
Maybe a giant trench isn't the best idea there.
This next one, just asking in general, what types of sensors work best in substrate growing?
I think this goes back to kind of what we previously touched on, but it ultimately comes down to understanding your sensing volume and what you're going to be growing in, regardless of the substrate. Most sensors perform really well in I'm assuming this is non-soil substrates that they're asking about. But for example, the Terrace sensors are really great for going into rock wool.
Especially the Terrace 12.
Yeah, especially the Terrace 12.
Temperature sensor in the needle itself.
Yeah, but in really small pots with maybe perlite or something else, maybe the EC5 is a better sensor.
And the EC5 works great in a lot of those smaller things. Not so great in rock wool, but the smaller propagation tubes and cells, it works really well.
Yeah, and if you're ultimately worried about it, the best thing to do is a soil-specific calibration.
Absolutely.
Yeah, and then you can usually have really high confidence in your data if you do that. But it just really depends on what you're working with.
And we have those procedures on our website.
Yeah.
Do you have any insight on the best way to remove your sensors from the soil at the end of the season?
Just yank them out by the cable
No,
is what you should not do. unless you don't care about that sensor. So take the time to dig around it. If you need to pull them out, think about that on the installation. Yeah. Because finding your sensors is generally the trickiest part of getting them out. So, if you install them beyond a certain depth, like coming back for sensors installed deeper than a meter is really tricky. But when you're installing, if you know you're going to have to pull them out later, definitely come up with some kind of cable management plan so that you can find the sensor later and have minimal disturbance. Dig as small of a hole as you possibly can.
Yep.
This one guy once, I'm not naming names, just piled all of his excess cable in the hole after he installed the sensor. I think he gave up after quite a bit of digging because he never did find. It wasn't me. Don't look at me. I didn't. I may have done that a couple of times. So yeah.
Yeah, and I think this is something where the borehole installation tool actually is really helpful because you have a very consistent placement of the sensor in a line. And when you need to come back out, you can just offset your auger away from the sensors and auger those out and then just clear the soil out around the sensors. And it makes it a lot easier to remove them. Now, it's still not easy. I'm not going to say this is easy.
Getting it out without cutting your cables or something like that is still tricky.
Yeah. Now, this is an advantage that profile probes have is they are easier to uninstall and just keep an eye out in the future. There might be some more options coming out for that. But if this is a regular thing, then you might want to look at sensors like that are more easily removed. It depends on how deep you want to sense them. So they might work well depending on your application.
Next question, basic overview question. How is dielectric measured and what are the units?
Oh my goodness. So I'm not sure if the person who asked this question realized how big of a can of worms are being opened with this question. There's lots of different ways to use the electrical properties of a soil to measure water content, which from our point of view is the end goal. And some sensors actually measure dielectric. Some sensors cheat on the measurement of dielectric. And some sensors are kind of dielectric adjacent. The Teros line of sensors, our current offering measures the capacitance, of which dielectric is a major variable. So we don't actually measure the dielectric, but you can infer dielectric based off of a calibration that we made from capacitance to dielectric. There are sensors out there that measure the dielectric directly, and there are some big advantages to doing that. So if you're looking for a water content sensor, one of the questions to ask is, do I need dielectric? Do I need an accurate dielectric? And if so, then make sure that it's actually measured by the sensor that you choose.
And dielectric permittivity is a unitless value. It's just dielectric permittivity. We know water goes typically up to 80 in terms of dielectric permittivity. Soil's typically around 4 or 5. And we have lots of standards out there to test sensors in that are different values of dielectric permittivity. Some of them are very harsh chemicals that I would recommend, knowing what you're working with and taking proper precautions if you're going to mess around with those standards. But yeah, it is kind of, as Chambers said, it's a very fully loaded question.
This next question, I'm going to paraphrase it a little bit. Basically, they're just trying to look and see the relationships between satellite images, so satellite data, and soil sensors on the ground for work in intelligent irrigation.
We're going to see more and more of this, I think, as time goes on.
Yeah, and we're starting to see a lot more of this in the research, and as you go to these conferences, you see a lot more people presenting on satellite data. I think ultimately there's two things that impact when you're comparing sensors to satellite data: scale, right, and how deep is the satellite data actually sensing, and then what other factors are influencing the satellite data.
That's right.
And I think ultimately the two need to go hand in hand. I don't think you can trust satellite data on its own, but satellite data is super powerful with sensor data to scale to the field scale understanding of water content, especially if you're trying to make broad scale irrigation decisions. There's a lot of power there. So I think really what the relationship needs to be utilizing in situ data to validate our satellite data, and then using satellite data to upscale our in situ data to more field scale processes.
And as you mentioned, there's more and more of that research happening right now. So keep an eye at your local conferences or regional conferences and check out the posters and go to the talks.
Yeah.
How difficult is the calibration of dielectric sensors?
I'm assuming they're talking about doing soil specific calibrations here.
Yep. It's super easy.
It is. Now, I will say clay soils are much harder to work with than non-clay, than say sandy soils or silt loams. But we have some really great resources out there on how to do soil-specific calibrations. But one piece that I'm going to say is key is homogenizing the soil. We oftentimes see people trying to do calibrations where they're wetting a column of soil or a small container of soil from the bottom up, and you wind up with gradients of moisture in that, and it's really not a representative way to do a calibration.
Unless you're doing soilless substrates. If you're looking at soils, then I'm totally with you on the homogenization. Yeah. Soilless substrates don't always lend themselves to that, like if you're doing a block of rock wool or coco coir.
Yeah.
You might need to do something a little different. And we have that procedure online as well. The concept is the same. You want a range of known water contents for your substrate that you can fit the relationship with the observed readings from your sensor.
Yeah, I agree.
We've talked about really dry lands. This person is asking, how reliable are measurements in saturated and highly variable soil conditions such as peatlands?
That depends on the sensor and the calibration.
Yep.
And the range of values that you're going to see. But if you're using a mineral soil calibration on a peatland, your data are probably going to not be that great.
Yeah, I would definitely have to agree with Chambers here. The traditional mineral soil calibration might not perform as well in a peatland because organic matter is so high, and you're kind of bridging the gap between like a soilless substrate and a standard soil calibration. So in these cases, probably what really helps is just having a soil specific calibration. Salinity isn't usually too much of an issue here unless you're working in coastal marshes or something or along those lines.
Fertilized areas.
So really just having a good calibration to go along with that. But once you have that, most sensors should perform really well in these conditions. Now one other piece is if these sites are constantly underwater, you actually might be better served with a tool like a tensiometer or a water level sensor, because really you're primarily dealing with, just maybe some area at times where it's unsaturated but primarily saturated, and then you're just dealing with what the water levels are in those sites. So if it's a constantly wet site, you might want to look at tools like water potential measurements. And tensiometers are great because you get both the unsaturated conditions with the tensiometer, but when it does become saturated, you get the positive pressure influence of that on the tensiometer, and so you can also determine like what is the level of saturation in the site.
Next question, how do you measure soil water content at shallow depths of 1 to 2 centimeters, seeing as most sensors average over a sphere of about 5 to 10 centimeters in diameter?
This is why the EC5 is still a very popular sensor for us. It has a very small measurement volume. In a wet substrate, we're looking at less than a 250 milliliter volume. And so people have used this in really small containers. You can get it right up next to the surface. And you're right, a lot of sensors do have a larger sensing volume. So if you're looking at just that very, very shallow surface, you're going to want to find the smallest sensing volume available.
Yeah. And I mean, it's tricky to make measurements at that shallow of a depth, especially if you see big diurnal swings in temperature.
Yeah.
I mean, one other option, I think we've seen some people use the thermal properties measurements using like the 2-needle approach. They get specific heat to measure the water content that way, especially like you're doing like crust measurements. But it is tricky. I would say dig into the literature a little bit and see what people are doing.
This next individual asking about installation again, is there a reason why the TEROS 12 sensors are placed perpendicular to the soil instead of horizontal?
I'm 95% certain that he's referring to cavitation and basically the equilibration within the plant stem of why you can take pre-dawn water potentials and have it relevant to the soil because the whole system relaxes at night. Cool.
That is cool.
Heathens.
I think it's super cool.
Unbelievers.
Probably not super relevant to soil moisture. Oh, I guess
It's totally relevant to soil moisture.
Fair enough.
You
Fair
guys
enough.
are killing me.
All right. Ready to go.
Is there a reason why the TEROS 12 sensors are placed perpendicular to the soil instead of horizontal?
It really just depends on how you want to spread your sensing volume out, right?
Well, that and the shape of your hole in a smaller bore hole, we've got them perpendicular with the 3 pins vertical because that gives you the best contact with the soil. If you've got them horizontal on a small hole, then you'll have a gap in the middle.
Yeah. Yeah, but if you're doing a pit installation,
then you can do it whichever way you want.
Yeah, there is no real reason as to. I mean, there are reasons as to why we do it one way or another, depending on our installation method. Mm-hmm. But you can install the sensors in whatever orientation.
The sensor doesn't
you want.
care.
Yeah. And the thing that you just need to take into account there is that it does change what area of the soil you're sensing, which is nice. If you do it horizontally, you're spreading out more across that horizontal layer, and so you're averaging that out, and so it kind of tightens your window of soil moisture that you're looking at in the profile, which can be advantageous if that's what you want to do.
Right.
All right, let's talk about roots. If roots grow between the sensor needles over time, how does that influence the measurements, and how do we work around it?
That's a really tricky question. The reality is that roots are a constant part of the soil.
And they're everywhere.
Right? And the sensor is reading not just the roots, but any microfauna, any like earthworms or fungi in the soil as well. So there's not really workaround for it because in most cases, those are the soils that you want to know more about, and they're generally in some kind of steady state with their environment.
Yeah.
I don't know that you want to work around it, unless maybe to control for it. But then you have to have some kind of sampling.
I think it's just a part of the system, and you just need to measure it. It might also depend on the size of the root. So if we're working in trees, for example, or plants that have really large roots, that could present some problems in some ways. But I don't know if I've ever seen big issues from that. But I think it is what it is, and you just measure it and utilize those data to understand what's happening in the system.
Are there any sensors available to measure individual minerals?
Nope. I mean, that's typically when we're trying to get to the mineral scale, people are coming into the lab and they're doing X-ray techniques, doing various things like that. I'm not a mineralogist. I've been around mineralogists, and they use very different tools than what we typically use in the field. But I can't think of anything in the field that really lets you get to that scale. And I'm not sure why you would want to get to that scale in the field. That's a pretty small scale to get down to.
All right. This next question asking about Meter's experience developing soil moisture sensors for NASA's Phoenix rover. How and why did the sensor also record thermal conductivity? Were there any interesting findings from the mission, and how involved were you guys on the project?
That was a cool project.
Yeah,
we built the probe that measured, that took those measurements, that flew on the Phoenix rover. That was our contribution to the project. For more on this, I recommend you check out our podcast. I think it's episode 3, right?
There's episode 3, and then we also had a joint podcast with the Field Lab Earth podcast that's put out by the Tri-Societies.
Oh, which one was that?
It was a couple months ago, or a few months ago. Or actually, maybe it's probably been longer than that now.
Okay,
it's been a while. But they came onto that as well, and and talked about their experience, and primarily with Doug and Colin.
It's the We Measure the World podcast, episode 3. It's awesome. You should check it out. And there are some other good topics in there as well.
Yep.
This next question is asking about the installation tool. It looks very interesting. Is it a challenge to keep the sensor in place while you backfill with dirt? It looks like it could be a challenge.
Definitely something you have to be mindful of.
It is. And I'm sorry, Brad, it's soil, not dirt. I just had to throw that out there. You soil scientists out there will get that.
Yeah, look who asked it, too.
Oh, of course. We won't call them out.
Good. We'll keep that in our back pocket for later.
Yep. I love the installation tool, for one thing. It's been one of my favorite things to see come out, and especially for installing sensors at a variety of depths. My experience with it is once you get the sensor in the soil, it stays in place fairly well, as long as when you're backfilling, you don't hit the sensor, right? You just have to be careful with your backfilling. Backfilling,
there is a little bit of an art to it.
Yep.
You don't want to just dump all of your dirt back into the hole and then fill it up. You want to, place some soil in the hole, tamp it down, put some more in, tamp it down. And so that way you can be very careful with your sensor cables and kind of build support for sections of it as you go up. And by the time you get just an inch or two above the sensor, you're in pretty safe shape.
Yeah, and the best thing to do is when you remove your soil, lay it out in the order that you take it out of the borehole.
Oh, yeah.
And then you just work your way back down from the bottom and just do it in layers and pack carefully. I like to use either a wide wooden pole or a piece of PVC with a cap on the end of it to pack the soil.
We have this in our installation video, right?
Possibly.
I think so.
Good question.
Okay.
If not, we should get more resources out there on that. But just be careful for the sensors. As long as you install everything on one side of the borehole, it's pretty easy to keep the cables out of the way. Mm-hmm. And then you just work your way up.
We're going to go back to talking about soilless media. Can you discuss how soilless organic media, such as biochar, coco, coir, affects dielectric sensor accuracy? Does the physical shape and size of the pores holding the water being measured affect the measurement, since it affects the electrical path between the anode and cathode?
Generally, for the things that the sensors measure, it's materials like that don't make a very big difference.
No.
They are going to bring down the dielectric just a little bit, probably. That's more because of the extra porosity and the extra air in it than the materials themselves.
Yeah, it's just like increasing the organic matter. I mean, that's with any of these biochar, adding coco coir or whatever. If you're adding that to soil, you're just increasing the organic matter.
That's right.
Of the substrate. And
so unless it interacts with the water molecule in itself, and some soils can do that. It's why salt's a problem, where you actually kind of lock down the polarity of the water molecule and don't give it the freedom to move with the electromagnetic field. That's where they could be a problem. But biochar and coco coir generally don't have problems with that.
Yeah, and to address the part asking about the changing in the porosity and the pathways, that typically doesn't have an impact on the measurement, because what we're doing is polarizing water molecules and looking at that polarization. But one factor that can have an impact actually is higher clay content soils, especially with those 2-to-1 clays, that when the water that's bound in those inner layers of that clay particle can resist polarization, depending on the frequency that the sensor is operating at. So I think one thing to just think about there is knowing what type of sensor you're using and what frequency it operates at and what are its limitations. Some sensors have higher sensitivity to texture, and this is one of the reasons that it has that sensitivity, is because of the clay minerals and how they affect the polarization of the water molecule. But these types of things, biochar, coco, are not going to impact that.
Can it have a higher cation exchange capacity?
Yeah, I can, but I don't think it's not going to impact the measurement in that way. I think we've seen some amendments that have really high salinity that come with it.
Yeah.
I don't think biochar typically has too much of an issue with that. But I guess it depends on also where that material is coming from.
We'll hit this one. They're asking, they're saying, I want to create an AI-managed irrigating system, and my vineyard is fully covered by a Wi-Fi network. How can I best connect with your devices?
Our current offering only connects through the cell network. So if you have cell at your site, then you can get data to the cloud through our Zentra system. We are planning a series of Wi-Fi devices, so I think in 2 years we'll have options. Yep. Probably less than that, we'll have some things on the market.
Yeah. Nothing available right now, but I think in the future we'll see more options.
Keep an eye on us.
So we've got a two-part question. We're going to hit part one right now. What is the best sensor to track the excessive moisture content in the soil? What is the moisture ranges for these sensors?
I think most of the sensors that we offer will work well in this type of application. I don't know if you really need a soil specific calibration here. You might, depending on how you're compacting it.
For a mineral soil, the mineral calibration will probably do really well.
Yeah. I mean, most sensors should work well, except for maybe the 10HS. The 10HS is maybe the one sensor that...
In mineral, I think it should still do good. If you're in soilless substrates, it might not be as good a choice.
Yeah. Now one question is where you're installing these. If this is a geotech application, you might want to look at one of the more robust sensor options like the Teros line.
Also, depending on what questions you're asking, matrix potential or water potential in general, if you start to get positive pressures and you want to keep an eye on that, then the water content may not be the right answer, or it may be the right answer to the wrong question here.
Yeah. Going back to water potential and tensiometers again. Mm-hmm.
All right. And then their follow-up to that is, how about applications in asphalt pavements?
Asphalt's tricky. We've done it. We've had projects with success. There's also been projects that haven't been as great. Asphalt's just, it's just tricky, because how do you get the sensor installed? Installing it in such a way where the sensor doesn't get smashed by heavy machinery or things like that is really the trick.
Yeah.
I'm personally not a fan of installing in the subgrade and then running a bunch of heavy equipment over it. But I think it's been okay on occasion. The better ones I've seen have installed after the asphalt has been, but I'm not up to date on all of the applications out there. So
yeah, I mean it really depends on how well you can protect these items when you put them in. Like cable protection is critical.
Cable protection.
And you need to choose the right type of sensor. Like if you're going to do this, I wouldn't do it with anything other than the Teros line, because they're the most robust sensors.
Stainless steel and epoxy.
Yeah. And then the other part is planning for some sensor failure. Just, have some redundancy, because it's going to happen when you're compacting soil over the sensors, if you plan to do that. Or subgrade over the sensors. We've seen some examples of really good success. The Minnesota Department of Transportation recently got to see one of their studies, and they had 95% survival rate of the sensors, and they think the other 5% actually is likely due to programming issues on the logger. So they're still working through some of that. So I'm excited to see how that continues on. So
great.
They seem to do it really well, and so I would definitely recommend checking out what they did. And if you plan to do these types of installations, try to follow some of those guidelines.
We've touched on this a little bit already, but this next question is asking, how do you deal with extremes in salinity, both high and low?
Low salinity generally isn't a problem. Nope. At least I haven't run into it at all.
Yeah, me either.
High salinity, this is a case where if you're above, if you know your saturation extract EC is above 10 decisiemens per meter, a sensor that measures the dielectric is probably the best option.
Yeah.
There are some situations where you can calibrate a Teros sensor if your salinity is high. But there's a limit where you're going to exceed the ability of the sensor to respond at all. It helps to have some baseline data on what your salinity is, and then a lot of it is picking the right sensor for the job.
Yeah. The high salinity can be challenging, and if you know you're going to be working in that environment, a soil specific calibration is probably going to be pretty critical.
Yeah, that's right.
This next individual is asking, do you think a dielectric is a more accurate option than a pressure chamber? And they're working with almonds.
Sounds like it's using leaf water potential versus dielectric sensors. And that's really comparing almonds to pistachios, if you'll allow it.
Well played, Chambers.
Yeah, sorry.
Yep. I mean, we all know the challenges that pressure chambers have and trying to do those measurements and the interpretation of that measurement. But again, we're asking two very different
You're looking
things.
at a different value than the point sensor.
Yeah.
Than the point value of a dielectric sensor.
Yeah. Now the better question might be soil water potential versus plant water potential.
I still don't like it. Yeah. Well, no. Again, it's not the same thing, because your point measurement, where your leaf measurement is going to be an integration of some soil water potential.
Yep.
And how can you identify that? That's one of the main questions that I have.
Yeah.
Whereas your point measurement, you know what the matrix potential is at that point. There are really good sensors out there for that now. But where is your leaf getting the water from specifically?
Yep. And see, this is how you know Chambers is the ecologist and I'm the soil scientist, because I would just say, well, this is just measuring the soil. It's easy.
Two different things.
This next question, they're asking for advice for tree plantations, probably orchards, soil moisture. Is there any limitations, any patterns they should work with, installing instrumentation, all of that kind of stuff?
You know, I think when trying to install, really the question is, how do you install sensors for trees? Regardless of the layout of the orchard or the plantation or however that's set up, is what is the root zone for that plant? Where is it getting water from? I think sometimes we either underestimate or overestimate how deep that plant is able to access water.
That's right. Start with where to measure the value you want to measure.
Yeah. So is it these young trees or young plants that you're planting that aren't going to be accessing water as deeply? Then you're going to want shallower sensors. But as they get more mature and they get deeper rooting depths, then depending on the plant, like pecans can access water from really, really deep. And so this can be really tough to try and utilize sensors at the right locations to understand the availability of water for those.
This may also be a case where it's good to measure matrix potential and water content.
Yep.
Because that way you get your storage, you know how much water there is to use. If you're measuring evapotranspiration as well, you can kind of look forward to when your tank is going to be dry.
Yep.
And then the matrix potential will give you an idea of what your water status of that tree is right now.
Yeah.
But watch out for spatial variability. I think that's the tricky part.
Yeah, and also your irrigation system. Are you flood irrigating? Is it drip irrigation? Where's that water coming from? You need to make sure you're measuring in those right zones.
When we want to irrigate from a minimum percentage of soil water moisture, which depth will we take into consideration? An average of 3 depths or only the 15 centimeter indications?
You know, again, I think this question comes back to where is the plant uptaking water from? Mm-hmm. You need to take into account the whole root zone, not one depth in particular. You just need to know what that root zone is and take all those measurements into account. I don't know if you would do any weighted averaging. So my experience is it's agonizing to watch your roots develop, right? Mm-hmm.
Especially if they haven't reached your sensors yet. You know your plants are taking up water and your water content or your matrix potential hasn't budged where your sensor is.
Yep.
And it changes over time. Eventually your roots are going to get down there. They're going to start taking water around the sensor. Do they move past it? Does the water source get deeper?
Yeah.
And so kind of getting a feel for that. I think it's helpful to have a sensor beneath the root zone, just so that you can see, especially if you don't have a water table down there, you can see, what's happening beneath your root zone, what water is getting through.
Yep.
But then again, in the root zone is generally the most important data that you're looking for.
Agreed. Yeah.
All right. Looks like we're up to the end of our time. So this is going to be our last question. And this final individual is asking, how is the sensor-to-sensor repeatability on the Teros line of sensors?
Our Teros 11s and 12s are 0.011 meters cubed per meters cubed. That's the 95% confidence interval for the sensor-to-sensor variability.
Yep.
And that's about as good as it gets, I think.
I think it is, and
business.
This is an area that we've spent a lot of time focusing on, because it's so critical that we have consistent performance, and we expect to be able to install sensors from 2 years ago and this year and have them behave as close to the same as possible.
And you're almost always comparing data between sensors.
Yeah, yeah. And we spent a lot of time trying to develop tools to actually characterize this, and we have tools like our capacitance clips that help us understand what the actual variability is of these sensors, taking out any other factors that could influence this. So, yeah, it's something we spent a lot of time on. I think we're pretty proud of what we've done there.
And the verification clips are a great tool to know what your sensor is, whether it's in or out.
Yeah, so very, very good repeatability.
That's going to wrap it up for us today. Thank you again for joining us. We hope you enjoyed this discussion, and thanks again for all of your great questions. Please consider answering the short survey that will appear after we finish, just to let us know what types of Q&A themes you'd like to see in the future. And for more information on what you've heard today, please visit us at metergroup.com. Finally, look for the recording of today's presentation in your email, and stay tuned for future Meter Office Hours events. Thanks again, stay safe, and have a great day.